Alright, so this video is on deriving the unit circle, the different numbers that are on the unit circle. So you have two sheets for this video. One is the blank unit circle. The other is going to be this sheet where we're going to kind of show our work for how we're deriving the unit circle. This is not something I'm going to ask you to do again. It's just kind of interesting information. And it'll be helpful for remembering where the numbers come from. So the first thing is a unit circle has a radius of 1. That's why they call it a unit circle. And so the easiest x and y coordinates to fill in are going to be the ones that are on the quadrant lines. So from here, if this is 0, 0 right in the middle, we can go to the right one. So this would be 1 for x and 0 for y. We can go up 1, so that would be 0 for x and 1 for y. We can go left 1, negative 1 for x, 0 for y. And then we can go down 1, so that's 0 for x, negative 1 for y. And we already know what those measurements are for the degrees. We've got 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So those are pretty easy to fill out. So what we're going to do next is we're going to figure out the rest of these by building triangles, and actually special right triangles, which you studied in Math 2. So that's what we're doing here. So if you guys recall from Math 2, we had two triangle relationships that we studied. One was a 45-45-90 triangle. The other was a 30-60-90 triangle. So the 45-45-90 triangle had the relationship where these are the two 45-degree angles. And it's an isosceles triangle, so if the base angles are the same, that means that the two sides that are across from the base angles are the same. So I said, okay, if this is a length of A and this is a length of A, then the hypotenuse is a length of A square root 2. And then for the 30-60-90 triangle, this would be the 30-degree angle. This would be the 60-degree angle. So this is the shortest side, that would be a length of A. The hypotenuse would be a length of 2A. And then this medium side would be a length of A square root 3. And so that was kind of the relationship between the sides. So what we're going to do first is we're going to look at this line right here. If we were to take the unit circle and draw a radius from the center of the circle to the edge of the circle, right here. Here's our x and our y coordinate. So we have an x coordinate, we have a y coordinate right there. I'm going to drop a line straight down right here. So I have just built a right triangle. And since this is a unit circle, the radius here equals 1. And then you can see that to get to this point, I went right this amount, so this is going to be a length of x, and I went up this amount, so this is going to be a length of y. I went right x, up y, and I got to xy. And right here, this is going to be a 30-degree angle, and up here, this is going to be a 60-degree angle. So what I can do now is, since I know this is a 30-60-90 triangle, then I know that the three sides are going to have this relationship here, where it's going to be A, 2A, A root 3. And because it's on a unit circle, I know that the hypotenuse is a length of 1. So if the hypotenuse is a length of 1 and the 1 equals the 2A side, then I can solve for A and I can figure out what the measurements of all three sides are. So I'm going to say 1 equals 2A. So I'll go ahead and solve for A. I'll divide by 2, divide by 2, and so A equals 1/2. Okay, so the plane A side, that's the short side, that's 1/2. Y equals 1/2. And then the other side is A multiplied by √3. So we have A multiplied by √3, which is 1/2 multiplied by √3. I'm going to take the √3, I'm going to turn it into a fraction by putting it over 1. So this is √3 over 2. So that means this side is √3 over 2. So if I want to take this point that was an x-coordinate and a y-coordinate and actually write down what the x-coordinate is and what the y-coordinate is, the x-coordinate is √3 over 2. The y-coordinate is 1/2. So for the 30-degree angle, you go to the right √3 over 2 and up 1/2. So we're going to go ahead and do that on our unit circle. I'm going to start with the 30-degree angle, and I'm going to go to the right √3 over 2 and up 1/2. To the right √3 over 2, up 1/2. Okay, now here's the triangle right here, but that same triangle is actually over here as well. So we've got 30 degrees. Now 180 minus 30 degrees, that's 150 degrees. So left √3 over 2, up 1/2. Okay. Now if that's 180, we can build this triangle down here as well. So 180 plus 30 is 210 degrees. So we can go left √3 over 2 down 1/2, negative √3 over 2 down 1/2. And then we can do the same thing over here. This would be the same triangle right here. 360 down 30 degrees would be 330. We can go right √3 over 2 down 1/2. Right √3 over 2 down 1/2. Okay? All right, let's try the next one. So the next one, similar story. So I'm going to go ahead and write this. I have the point x, y. I'm going to draw this line straight down. I'm going to make a 90-degree angle. I'm going to say the radius equals 1. So here we go right a certain amount and up a certain amount, and we go to the point xy. So this is right the amount of x, up the amount of y. And this we're going to say is a 60-degree angle, which would make this a 30-degree angle. So you can see that it's actually the exact same triangle. It's just oriented differently, so it's kind of flipped around. So since it's a 30, 60, 90 triangle, and the hypotenuse is 1, I actually have the same relationships that I had last time. So I still have 1 equals 2a. I can still divide by 2. I can still say a equals 1/2. So the short side of my triangle is still going to equal 1/2. It's just that the short side of my triangle is in a different spot. The long side of my triangle is still going to be a multiplied by √3. So it's still going to be 1/2 multiplied by √3, and it's still going to be a length of √3 over 2, just like the previous triangle. It's just that this side is going to be over here because the long side happens to be the height of this triangle, √3 over 2. So this point, instead of going right √3 over 2 up 1/2, this point goes right 1/2 up √3 over 2. Right 1/2 up √3 over 2. So it's really similar because it comes from the same special right triangle, but it's just oriented differently. So let's go ahead and fill that out on our unit circle now. Right? So we're going to look for the 60-degree angle on the unit circle. We've got 60s right here, right? It's 30 degrees off of 90. And we're going to go right 1/2 up root 3 over 2. Okay, now from 180 up 60 degrees would be 120. Okay, and we go left 1/2 up root 3 over 2. Okay, and then from 180, we go 60 degrees, and so that's going to be 240. We go left 1/2 down root 3 over 2. And then from 360, we go down 60 degrees to 300, right 1/2 down root 3 over 2. Okay. Go ahead and flip the page over. So we've got one last picture to look at. Again, we're going to go ahead and say that we have this line from the center of the triangle to the edge or from the center of the circle to the edge, that's giving us a radius of 1 because this is a unit circle. We're going to call this the point xy, an x coordinate and a y coordinate on the unit circle. We're going to drop a line straight down. We're creating that triangle, that right triangle there. So to get to this x and y coordinate, we would go right a certain amount and up a certain amount. So this is the x value. This is the y value that it takes us to get to that point, right and up. And this is a 45-degree angle. So if that's a 45-degree angle and that's a 90-degree angle, that means that this has to be a 45-degree angle as well. So if we look at this problem, these are the two base angles. That means that x and y are the two legs that are the same. These are the two values that would be a and a, which means that r equals 1 is the hypotenuse. So if I want to solve for the a value to figure out what these two would be, I'm going to have to take that hypotenuse, which equals 1, and I'm going to have to set it equal to a root 2 to figure out what a is. So I'm going to say 1 equals a root 2, and I'm going to solve for a. And when I solve for a, I'm going to know what both x and y are because both of those are just a plain a. You can see both of those are just a plain a. Okay. So I'm going to go ahead and solve for a. I'm going to divide by root 2. So a equals 1 over root 2. This answer is not proper in math. We cannot leave a square root on the bottom of a fraction, so we have to multiply by another fraction that is equivalent to 1. So I'm going to multiply by root 2 over root 2. On the top, 1 times root 2 is just root 2. On the bottom, root 2 times root 2 is the square root of 2 squared. And the square root and the squared cancel. And so I get root 2 over 2. So both of these are just the a value. And so both of these equal root 2 over 2. So to get to this point, we go right root 2 over 2, up root 2 over 2. Right root 2 over 2, up root 2 over 2. Okay, so let's look at our unit circle. In between 30 and 60, we have a 45-degree angle. And to get the x and y coordinate, we go right root 2 over 2, up root 2 over 2. Between 120 and 150, we have a 135-degree angle. To get that point, we go left root 2 over 2, up root 2 over 2. Between 210 and 240, we have a 225-degree angle. To get to this point, we go left root 2 over 2, down root 2 over 2. And then to get to our last point here, we have in between a 300 and a 330-degree angle. We have a 315-degree angle. And we're going to go right root 2 over 2, down root 2 over 2. So you'll notice that our first quadrant points always have a positive for the x-coordinate and a positive for the y-coordinate. Our second quadrant points always have a negative for the x-coordinate and a positive for the y-coordinate. Our third quadrant points always have a negative for the x-coordinate and a negative for the y-coordinate. And our fourth quadrant points always have a positive for the x-coordinate and a negative for the y-coordinate. Now, don't worry about doing any more of the notes. We will finish these in class tomorrow.